Okay, welcome everyone to the Flux Dev Meeting, July 10th, 2025. Do we have any agenda items who'd like to go first?
I can go first. Just some news. We've published a new blog post on the Flux website around being able to do deployments only during maintenance windows with Flux Operator. It's a new API. It's like it allows you to specify a series of cron jobs, and it will only trigger a Git pull or and chart fetch from the container registry in those particular time windows. And while this is not something we would get normally into Flux being a continuous delivery tool, so you should be doing continuous delivery. If you actually merge a thing, it should go where it's supposed to be. Given that it was like a requested feature that comes on and on, we figure out a way to implement in Flux Operator, which has these high-level APIs without messing with the Flux reconciler. And how this works, Flux allows you to pin Git repos on a particular Git SHA, on a commit, or on a particular OCI artifact digest. What it means that even if you set an interval, Flux will continuously reconcile, but for that shower digest, which are immutable, right? So even if source controller always check the upstream source, it will not find something new, right? So it doesn't alter in any way with how Flux works. And the major advantage of this is compared to what we tried to build in the past, gates inside Flux, and we decided it was a no-go. The problem was that if you tell Flux to stop reconciling, let's say you tell source controller pause for Friday, you shouldn't be doing any deployment, right? No deployment Friday. And during Friday, the controller restarts, or the node where source controller is needs to be recycled or some reason out there, and the source controller storage gets wiped. If it starts, right, it will not have the artifact in the cache. It will not be able to reach the artifact because it only don't do anything in that particular time. And what that will result in, the disadvantage is that while you are in the state where source controller has no desired state, customized controller and handle controller not be able to correct drift, right? If something changes in the cluster, it will error out, hey, I can't get the desired state to actually be able to undo kubectl edits or the things, people expect Flux to do. This approach where you pin the desired state to an immutable point, like a shower or a digest, it doesn't matter if source controller restarts, maybe you don't have persistent storage for source controller. When it restarts, it will go in to the Git repo or the OCI repo, but it will get the identical desired state based on that digest. So that's how we kind of solve this issue. So that's what the blog post is about. Other news, the FluxCon CFPs have ended, and now we are entering the review time, and we are going to publish the schedule first week of next month. So the reviews will have to happen by the end of this month, and probably somewhere in August we'll know exactly what talks will get in. We have lots of CFPs, but only half a day, so don't feel bad if you don't get your talk accepted. We can only choose 5 talks, and we have, I don't know, more than 30, 40, something like that. So
38.
38, yeah. So they are not. There is no guarantee your talk will get in. It's up to the committee, the 10 people that will give different ratings on each talk, and that's how uh, the CFPs will win. It's the same procedure as everything on KubeCon. We are not doing anything special. We are following CNCF rules on that. Yeah, that's it from me. Oh, other things, we are pretty good on the roadmap. We did some updates this week. We are moving forward with the workload identity features, and we have expanded a little bit the RFC to cover connecting to remote clusters. What that means, so today you would set a kubeconfig field in hand release or Flux customization that points to a secret that has a static kubeconfig in there. So the controller will read the kubeconfig and it will connect to the remote cluster. That means you need static credentials and all of that. And Mateus is working now on taking what we've built for how to connect to, let's say, a container registry, or what Deep built for Azure DevOps, how to connect to a Git repo without static credentials through OEDC and workload identity. The same exact procedure we want to apply for connecting to remote clusters. So instead of having a kubeconfig in a secret, you'll tell the controller, use this identity, get an ephemeral token, connect to the cluster, cache the token for a particular time. I'm guessing, Mateus, we have the same caching procedure right in place with 1 hour
Which is
expiry and all of that.
basically, yeah, like basically we expire on 80% of the life of the token, but it's always kept at 1 hour. And
Okay.
the users have a binary flag in the controllers to decrease this to less than 1 hour. It can never go up above an hour. It's always kept.
And this is the same. I mean, the procedure is the same no matter if you cache a token for a container registry, for Azure DevOps, for an AKS cluster, GK cluster, and so on, right? It's the same.
Yeah, the token interface has a single method, expires at, and
Yeah,
that's what the token cache library
yeah.
uses.
So we are reusing the same mechanism we have for connecting to sources, and we are expanding that to connecting to remote clusters. While running Flux on a management cluster and have it as a single point of failure for your whole fleet estate is not something that we recommend. We are well aware that due to different constraints for different organizations, they are required to run in this mode where there is one cluster that has to pull
Hub and
everything, then
spoke.
connect to everything. Hub and spoke, yeah. So to make hub and spoke safer, uh, and hopefully easier. I don't know how easy it is to configure all of that. Depends on how good the docs are, Mateus. Yeah, we are going to ship this in 2.7. And thank you, Deep Deep, for
Testing.
testing out. Yeah,
Oh
yeah,
my
thank
God, you found
you.
a mad bug. Thank you so much.
Yeah.
Like, yeah, Dipti found this bug where I wasn't in the integration tests, I wasn't exercising runtime client impersonator. Now I am. So there was a bug there. It's fixed, and I changed the test to use this part of the code that customized controller. It was working in help control. It was not working only in customized control. Thanks very much.
Yeah, no worries. I have a few more tests to run just from the object level identity perspective, but everything I've done so far is looking good now. There was one small thing with the casing and this one, just two issues now. Yeah,
I also fixed that. Thanks very much for finding. That's a very good find.
thank you.
Out of curiosity, did we find the bug just off of instinct, or did we find it because we implemented a test?
Testing end to end. Like we were testing customized controller with the feature, and it didn't work at all. Would never work. So
So I think the
we found
integration
it.
test lead, they work only at a package level, right? But
Mhm.
when we
Yeah,
tried
I
it
was
all the
using.
way
Yeah, I
from the
was
customized
using.
controller.
Yeah, I was using only what's in the auth package. And in customized controller, it's a combination of auth package with runtime client package. And now
Especially-
the integration test is testing with both.
Especially when we're juggling clients. I don't know how helpful this comment is, but we should just make sure that we write tests that not only are looking for what should work, but looking specifically for privileged things that should not work. Like we should have tests that are like trying to do things that they should not be able to do and like assert that they fail. And then that can
Sounds
that
good.
can catch when we're not impersonating and that sort of thing.
Sounds good. I'll add a few. Good idea.
Yeah,
And also,
I mean,
sorry.
wait a second on this note. Like, how you like right now, if when you create a static kubeconfig, right? You create it for a particular service account that can be binded to cluster admin or whatever, right? How is that currently working when you do not object level personation? When you say, I grant
Spec.service
customized
account name.
controller, yeah.
It's an impersonation. It's like what's in the kubeconfig is used for authentication. So authorization HTTP header with a bearer token, and impersonation spec.service account name goes on special HTTP headers that Kubernetes has for impersonation. So you send your credentials and the service account or username, actually username and groups that you want to impersonate. So we set there's code in our impersonator code. We have username, system, colon, service account, colon, namespace, colon, name, and that's it. We don't impersonate any groups, only the service account username.
Yeah. Of course, that's in the impersonation level. What I mean is me as a user, I have two clusters, one where Flux runs and another one, right? Now I don't want to create a static kubeconfig for a particular identity. I want to use workload identity. How can I say I want to bind this identity to something in the remote cluster? Will I be using the same service account that I'm impersonating, or
it's the same thing as static kube config. The temporary token associated with the cloud identity is what we use for the bearer token for authentication, properly said. And spec.service account name is what is used seamlessly with the code that does the impersonation in our code base. Doesn't know if the kube config comes from a static one or a temporary one.
That I understand what I'm asking about. I don't use Flux multi-tenancy. I don't have spec service accounting. When you run on a normal cluster with no workload identity, right? If you connect to the management cluster, I'll be using cluster admin for customized control. When I'm connecting through the static kubeconfig, I will be using whatever is in the kubeconfig. How is that working when you don't have a kubeconfig? You just have a workload identity.
When you don't have a service account name, right? When you just have the temporary token. Yeah. So the cloud identity is the identity with permissions in the remote cluster. And the way the permissions this cloud identity can have in the target cluster come from two sources: Kubernetes RBAC and Cloud RBAC. So Kubernetes RBAC is just plain Kubernetes RBAC, like role bindings and cluster role bindings objects in the target cluster, referencing a special username. The username varies according to cloud provider, obviously. And the other
okay, so there is a username. That was I was asking. Okay.
Yes. So Kubernetes RBAC, there's a username. And the same username is also associated with Cloud RBAC. So
Cloud identity. Okay. Yeah, of
Yeah,
course.
so all of the clouds
Okay.
have these. And by the way, I thought that this was like a conversion the clouds were doing into special role bindings and cluster role bindings, like converting to Kubernetes RBAC. That's not the case. What happens is actually every cloud will first try to authorize the request with Kubernetes RBAC. If that fails, they still invoke a webhook to the cloud to verify if the cloud identity has the cloud permissions. So that's how it
Right,
works.
I forgot about that. There's
Yeah.
a different
Yeah, you asked me that, right?
authorizer,
Yeah.
and the authorizer
Yes.
is part of the cloud provider plugins that broke out of Tree. Okay, so
Exactly.
API server also asks if. Okay,
Yes.
nice.
And
Cool.
to give even a little bit more context in this subject that is interesting. Yesterday we got a feature request that is for workload identity for the generic provider. So basically, I didn't know about this, but in Kubernetes, you can configure external OIDC issuers and trust on them and have rules that map the JOT to a username in the cluster. So with this, we can use you can use Kubernetes OIDC on both ends. Like we can use the management cluster can issue JOTs, and the remote cluster, the workload cluster, can accept those JOTs. They can be configured to accept that. And we got a feature request for this yesterday, and yeah, I'll add it. It's pretty cool.
I put it in the notes. Pretty nice technical spec from somebody who took the effort to explain what their setup is and what parts would be.
Yeah. I definitely learned something from them yesterday. Yeah.
So with this JOT that gets accepted by the worker cluster, the remote cluster, that means you can use cluster API without having to point Flux to the kubeconfig that's generated in cluster, which is always cluster admin, because that always felt like kind of risky to me. Like,
Yes.
yeah, it's great, it's a convenience, it's there, but it's cluster admin. So unless you turn on multi-tenancy, if you don't turn on multi-tenancy, then you are cluster admin not only on the management class, but everywhere else, because all these kubeconfigs have cluster admin.
And I'm not sure if you saw in the thread from this user, they are still using this kubeconfig, this admin kubeconfig for add-ons and tenant RBAC. But then for the other customizations, they want to drop permissions.
Of course,
So
yeah. I mean,
it's
if you
perfect.
install the CNI, of course you need cluster admin. But if you deploy, I don't know, some app in a namespace, having a kubeconfig with cluster admin and that being the only thing, it's quite risky, right? And we solve that by saying to people, you need to implement Flux multi-tenancy. Then you have to create a service account and RBAC for it in the namespace where the app gets deployed in the remote cluster, right? So impersonate that. But now if you can, there was another big problem here. And it's about coupling. When you have cluster API and you have a cluster definition, you put that in a namespace. And in that namespace, the CAPI controller will create this kubeconfig. Now, a Flux customization and a Flux end release cannot refer to a kubeconfig secret across namespaces. We don't allow that. So we forced everybody into putting all the Flux objects in the namespace where the cluster definition is. And this is kind of messy. What if you deploy 1,000 apps? You need to put all the apps, all the add-ons, everything in the management cluster in a single namespace where the kubeconfig is. Or you have to copy the kubeconfig from there to other namespaces, and when the kubeconfig gets rotated, you need to copy it again and so on. So it was like ergonomic issue in the end, right? You're forced into this namespace.
Yeah. We
Is
may
my
still-
assumption correct now? Wait a second. Is my assumption correct now that you can have a tenant namespace in the management cluster where there we don't have the cluster admin kubeconfig, and only point in the Flux customization, I want to use this cluster and this user without having at all the kubeconfig secret there. Will that work, Matej?
Yes, in several different ways. Like you can have several options. Actually, a couple. So you can, so without the static kube config, you will have.
You need the CA.
Actually, yeah, you still need the CA. The CA is not a secret, right? I'm
Right,
just
right.
adding as a, I'm just adding as search secret ref to be consistent across the Flux APIs, but it's not really a secret, right?
Yeah.
And so what you have here, you have like three or four different options. You can set spec.kubeconfig.serves account name. You can set spec.serves account name, and you can set controller level. Like, and all of that are identities that can have whatever RBAC you configure in the remote cluster. And they are completely separate from the static kube config. So you can, so what you're going to be doing here, you're going to use a combination of authentication with impersonation, right? The impersonation always comes from spec.serves account name, which is optional. But the authentication, the token, will come either from controller level, so you leave spec.kubeconfig.serves account name empty and use the controller serves account, or you set it to a specific serves account in your namespace, which has to exist in both clusters, right? Always remembering that when we actually the only namespace that has to exist in both clusters is the namespace of the customization. Of course, it's the namespace we're talking about, but that's for spec.serves account name. Spec.kubeconfig.serves account name. And if you leave it empty, the controller serves account, those must, like, the user has to configure the target cluster to map those source accounts properly. So in the Kubernetes configuration for accepting an external OIDC provider, you have this possibility of building the username that will be impersonated inside the cluster. You can say extract claim sub and prefix it with this string. That's exactly what they're doing, right? The person who asked for this feature, they are prepending management cluster : to the subject, which is an important thing to do because it's a different user inside the cluster with permissions only for that user that comes from another cluster. That's something we probably need to highlight very well in the docs.
Okay, so when you do multi-tenancy on a single cluster, usually you have Flux running under cluster admin that provisions the namespace of the tenant, the service account, and the RBAC for the tenant. Now, can we have the same thing? Let's say in the namespace where I have the cluster definition, I'm putting there a customization that references the static kubeconfig with cluster admin. And that one provision all the namespaces in the tenant cluster along with the configuration of
Tenant
this,
RBAC.
the tenant RBAC with this prefix. Okay, cool.
This
So it doesn't change
the
much.
prefix is not configured here, right? That all these things we're talking about right now, they don't include the prefix. It's the So I don't know if Copy has some API for this specific part of
It should in
configuring API
the
server,
cluster
right?
API.
Yeah,
Yeah.
right. Okay, so in the cluster API, you should be able to configure this prefix and everything. Cool.
Yeah.
Then yes.
And
Answer
then
is yes.
with Flux, I can create a namespace. I can create a role binding for that particular identity in that namespace. So then I'm granting the Flux objects in the tenant namespace, the management cluster, enough rights to first connect to the remote cluster, then be able to reconcile a Helm release or whatever customization under that RBAC. Only that's limited to one or more namespaces which are belonging to a tenant. But Flux should be able to configure everything, like create a cluster with copy, then create a namespaces as cluster admin in the remote cluster, set up role bindings for this special user, and then the other Flux that runs under impersonation, right, should be able to deploy everything with just a depends on between basically the tenant namespace and the tenant customization. We have a depends on the cluster, on the Flux customization that creates the cluster object. We have now custom health checks. So Flux knows how to wait for cluster API to actually create the cluster is healthy, and only then we connect to the cluster and deploy add-ons and tenants. Yeah, okay. Yeah, so we have this hub and spoke example repo. Maybe
we can evolve it to use this, right?
Yeah, I'm thinking either we can create in there a branch where, so how how is built today is pure kind clusters, no cluster API in there, because kind, when you run more than one cluster in the same Docker engine, you have a shared network, so they can connect to each other, right? And that's how it's set up there. No cluster API, just kind create cluster, kind create cluster. Then I'm saving the kube configs from all the worker clusters to the management cluster.
Yeah.
Right.
You won't even need to, in the kind setup, you won't have to create kubeconfig secrets. You can just make sure that the issuer configuration is inside of the API server component config for all of the spoke clusters.
No, but I mean, I had to, because this is how Flux used to work.
That's what
right?
I'm saying is for this branch, like instead of putting the secrets into the clusters, you just need to configure API server's authorization config with the API server component config to have the OIDC prefix mapping. And then Flux can be configured to do the same multi-tenancy split.
Nice. Okay.
Okay,
So let's
Hey, sorry,
create
I
this
had
as a to-do for after 2.7. I think it's great work, but you also need an example.
yeah. It's
Way,
complex, right?
if we can do it with kind, and if anyone can run it on their local machine and see how all of these gets configured, I think that's really powerful. Like a lot of people didn't understood how to set up the kube configs, how to do the hub and spoke. After I created the example, that was
But
a lot
we
of
will
people told me
make
like, no, I get it, now it's easy and so on. Right?
but does kind integrate with copy?
Yes, there is a kind provider, rightly?
there is a kind provider intended for CAPI development. Also, I kind of characterized the previous statement a little bit incorrectly. It's like you would still need the role binding to be in the spoke clusters. So you might want to provide an example of the kind stuff where there is the secret and then you're doing the pivoting from the secret to the
Oh,
workload.
Yeah, the
so
whole
we
thing.
want to start with the secret,
Yeah, you're
but
right.
then be able to create a Flux customization in another namespace where you don't have the secret and demonstrate, yes, you can now you can connect and deploy under a particular role binding on the target cluster. So I'm not saying if we can get away without using kind, without using copy and only kind, that
Yes.
will be perfect. If we can
Yeah.
keep it that simple, because kind has its own controllers, it's
Yeah. Or Cappy. Yeah.
copy, yeah.
Mateus, just context on Cappy and kind. Many Cappy providers, it's not required, but many Cappy providers use a couple of custom resources that are specific to using kubeadm to initialize the cluster. And that is the part of the Cappy API where this authorization API server component config is exposed. The API server component config is its own API. And that's formal. Like, even if you're not using kubeadm, you should be able to configure API server to do this.
So, but the high order bit that we want to show in this example, is it just the ability of the feature itself, like the
Yes,
multi-tenancy of it?
we
So
don't need to
it's not the
necessarily
provisioning
show
cluster
the
static kube config.
No.
That's not important here. Okay.
I have a bunch of example repos before of doing this Cappy kind demo that will also totally work with this technique, but we don't, it's much simpler and much more performant. Like it takes really long to use Cappy on a local machine.
Yeah.
But kind is super fast and everyone can run it and it
So
maps.
Mateus, if you look at the repo that we currently have on paste here, so in this one is extremely fast and easy to use. There is a simple bash script that does kind create cluster, kind get config, applies the kube config on the management cluster, then deploys Flux, and that's it. Ideally, we would start with this, the identical setup, but then we need to figure out how to do the trust between the clusters and show people you can actually create the tenants in a dedicated namespace on the management cluster where the cluster admin kube config is not there, and it will connect to the a target cluster deploy under that role binding. Right? So it's not about even demonstrating copy, it's about demonstrating how
The
Flux
feature.
can do it. Right?
Okay. Sounds good.
There's some UX things here. One is the example repo. Even though it's focusing on kind, we can have in a README or an example YAML what it looks like to configure Cappy with this authorization thing inside of the kubeconfig
Yep.
area. That'll be a good breadcrumb for people. And then also from a usability perspective, I think when we're thinking about the API fields, right now, like the URL of a Kubernetes cluster, it's sort of a dynamic output of Cappy or whatever, Gardener, anything that's creating kube clusters for you, and the CA configurations as well. Getting those field names is going to be like a little bit of a pain in the ass for people. So
True.
thinking
It
about
can't be
ways,
fully automated. Yeah, that's a
can you
good point.
structure a customization to read the field name from
And since you're at it, I
a
have
config map,
another.
or should we use Flux operator with copy from, and then how do we make it so people aren't copying the PKI for the certificate, the client certificate that has like cluster admin, like separating those things since it's all in one fucking like secret, excuse my language. But
One thing we could do
yeah.
that doesn't look very good, but it's helpful from that perspective. It's still using the kube config and extracting only what we need. Like we only need the CA and the endpoint, the token we generate, right? But
Yeah, and the cluster address as well. And
the
like,
API,
but
like
yeah.
the API would be spec.kubeconfig.secretref and spec.kubeconfig dot something that says don't use the kubeconfig as is, but rather generate a token.
I'm experiencing visceral pain. Yeah,
Yeah.
it's like,
And by the way, let me add something here. Audience. I need to set an audience for the token. The
Yeah.
audience, as described in the issue opened by the user, they are saying they need the audience to be the address of the remote cluster, which is only natural, right? That token, the JOT is intended for that clusters. Yeah, audience should be the URL of the cluster. I will obviously fall back and default to the address of the cluster as the audience. But in the future, people may want to have more custom audiences because that thing is configurable. So I'm just bringing here that we may consider in the future Flux to dot something bigger than 7. spec.qconfig.audiences or something.
Audience template.
Yeah.
Um,
Yeah.
yeah.
There is also the problem with inlining all this stuff in the
Yes.
config.
I agree.
I would, if it gets so verbose, why wouldn't we have a ref to a config map? None of this has, like, the rule is if you do workload identity or the thing that's now possible with copy is the fact that all this information, nothing of it should be a secret. That's the whole point of it, right? You don't have
Yes.
long-term secrets,
Yes.
right? So
Yes.
how about we, instead of adding all these fields to the kubeconfig, we have a config map ref. And in there, like we have all these custom secrets for notification controller, for source controller, where we said, yes, you need to have all these fields. You need to have username and password if it's basic. You need to have for proxy, address, username, whatever. Maybe it is better to extend the API through a config ref that gives us the possibility to go as verbose as we want in terms of, like Lee said, oh, we'll probably need a template. We'll probably need some 3 other fields because whatever, one cloud behaves differently from the other, right? And all of that.
How do
And I
we
would only
intersect with
keep,
the existing fields? So, for example, there's address, right? Address is required for clouds, right? Specifically for Azure. And there's service account name as well. So I
no, I
guess
don't care about those. We treat them as a configuration. So right now you have kubeconfig secret ref, and we expect in the secret to have all the fields that a kubeconfig has for a static kubeconfig. Now we'll have config map ref to a config map where we tell people what fields it should have. And we create in the Flux CLI a command where you pass the address of your cluster, the service account name,
okay, so you're
all
proposing
the
to
fields
change
that
all
you
the
want.
API that we already have. We scrap that. So right now
No,
we have
we move that into the config map. So those fields,
right.
instead of being inline,
Okay.
it will be the specification of the fields in the config map. And in our API, you'll have config map ref. And when you don't use secret ref and use config map ref, automatically you don't have a secret, so it has to be workload identity or the generic with the
which is also workload entity. So yeah, all
which
the
is
4
also workload.
providers. Yeah.
And this gives us the freedom in the future to add as many configurations as we want without having this huge, because there is another problem here. In a namespace for a tenant, you may have hundreds of customizations, hundreds of hand releases, and they all will connect to the workload cluster to deploy this. That means you need to copy paste the address, the service account, the token scope, all the fields that we are now discussing in hundreds of hand releases. It's very annoying. you'll be forced into creating customized overlays so you can patch them into a single place. It will get very verbose in your desire state in Git. Instead, if you reference to a config map, you create a single config map in that namespace for the tenant with the specification of the cluster, the address, the service account, all the data, like we have now for the kubeconfig, and all the hand releases and customizations that need to connect to that particular cluster will just reference that config map. In the same way now it works with the secret.
And in that case, we shouldn't use search secret ref. We should use CA data.
No, you'll put it in the config map as well.
The search secret ref,
No.
the
Question.
CA,
So
right? Yeah. So I'm saying either it's a field in the config map that is called search secret ref, or inline the CA there, CA data.
no, always inline the CA there. There is no
Yeah.
point in having like two steps.
Yes,
right?
that's what I'm saying. So it's better if we just have a
Yes.
field called CA data and not search
Yeah.
secret ref.
Oh yeah. CA. No, we should have like how we call it in the current secret. The same key name should be CA.
CA.TLS.
Yeah.
CA.TLS.
Yeah.
CRT. Okay.
CRT. Yeah.
Sounds
So you have
good. Yeah.
CI, CRT, address, all these fields because they are not secrets. That's the whole point of it, right? That's why you put them in a config map. That's why we can make this distinction. It's secret, then it's a static kubeconfig, it's a
I
config
like
map,
that.
it's workload
I like
identity,
that.
right?
I
So
like that.
we don't get our API crazy verbose. People don't have to copy paste all these things, right? And we can easily flip between config map and secret.
And the config map is something that is more templatable from
It's readable
workflows.
because it's not
Yeah.
big. Yeah.
You can generate a config map with the stuff you want. I mean, a config map is also an object, just like the customization, right? But
Yeah.
I
So
don't
what
know
we
if,
need to do
yeah.
is create a CLI command in the Flux CLI. Like we have now for secrets, you should have Flux create, I don't know,
Secret. We
not
have the
secret,
command flux
config map.
create. Oh, config map.
Yeah,
Flux
because it's
create
a
config
config
map.
map. Maybe
Mhm.
we'll name it something else. I don't know. Flux create whatever, cluster info or however we want to call it.
Kube
So
config.
people can no, because it's not a kubeconfig.
But then we maybe should, so that's a point that Lee brought. We have the API is spec.kubeconfig.secretref today, right? And we are talking about spec.kubeconfig.configmapref. So it's going to be under kubeconfig. So I guess.
Oh yeah,
like
right. Flux create kubeconfig and I don't know
Flux create
workload
config map.
identity. No,
Flux create
workload
config map,
identity.
kubeconfig. Flux create config maps, kubeconfig.
Yeah,
Consistent.
something like that. We'll have to decide on it. But yeah, I mean, it will be nice to have a CLI command so people can generate the config map and they can generate any other things that are attached, right? Now, another interesting thing here is that someone will change the config map, right? So we should have watchers for this as well. The other thing we are discussing now to add watchers when
But
things that are referenced.
That will mostly be implemented by the watch, right? We just tell people to put the label. The watch part
Exactly.
is solved. We
Yeah.
just have to index by spec
Index,
dot.
yeah.
Yeah, we just have to index. Yeah.
Yeah,
Spec
And
dot
we
kubeconfig.
also
I like-
watch kubeconfig secrets,
probably a different
right?
index, but the same watchers. Yeah.
Yeah.
And then
I mean, the index is for this config map or secret, what customizations and ham release I need to trigger. So the indexing will be the aggregation of all the config maps or secrets that are referenced in the object. So that can be for ham release values from or spec dot
kubectl
dot
secret
secret ref config map ref
configure.
and spec dot for customize. There's also spec dot decryption dot secret ref as well.
And it's also variable substitution,
Yes. So the
config map and
aggregation
secrets,
of
kube config.
referenced things.
Yeah.
Yeah.
Customization is the most complex, right? Because it has
Decryption.
decryption as well. So it has variable substitution, which let's say is the same as Helm
Values
values
from.
from. It has kube config that will be identical to Helm release, and decryption, which can also reference secrets, right? So if we make this, if we react to external configuration, config maps and secrets, we have to do it for every single reference, not only Helm values or whatever, right? It needs to work across the board. And we already have figured out that we are going to do it by a label. So if you want Flux to react to anything, you need to label your stuff, and then we need to build a proper index so we always get triggered by the event.
Yeah.
Deepti, I don't know if you know what we
we
are
should give
talking
some
about.
context.
So.
Yeah, we should give some context here about these watchers.
So there is values from, right, or variable substitution from, and you point it to a config map or a secret where you can have there your can release values or your variable substitutions, right? And the problem is that if you change them on the cluster, the controller does not know that the config map or the secret has changed. So you need to wait for the reconciler interval. And the only solution now is to use the customized config map generator or secret generator. Because when you change something in a config map or in a secret, you'll actually change the name of that config map and secret. So you actually change the spec of the hand release or the customization that are referencing. Now, there are users which cannot couple the values, the config map with the values with the hand release in the same repo. Or in the case of cluster API, is the cluster API controller which generates the secret with the kube config. So there is no way of, you can't put that in your repo, right? It's something that happens in the cluster. And what people are doing to speed things up, they set 1 minute interval for the reconciliation of all the Flux objects, which is not great. It DDoSes your Kubernetes API. It has many, why you should reconcile continuously every 1 minute. And that's the only workaround right now. And what we want to do for Flux 2.7, and maybe you can help us here if Mateus will do Helm controller and maybe you can do customized controller, is watching for config maps and secrets and reacting to changes there. The issue is clusters have so many config maps and secrets. So we had the caching enabled for them a long time ago, and it filled the memory of customized and Helm controller, gigabytes of memory for nothing. So we have disabled that. So we don't want to bring that back and go out of memory. So our solution was, we are going to have these watchers based on a predefined label. fluxcd.io/watch equals enable. And only when you put this label on a config map or a secret, only then our controllers will get that from the API and will store it in the cache in memory. So we are not blowing up the memory usage. The goal is to only watch for the things that users know. Hey, I'm using this data as references in what Flux does, right? So then you don't have to set up 1 minute interval. You can set it to 60 minutes. Don't DDoS your Kubernetes APIs. And the moment a config map or a secret changes, maybe cluster API rotates the kube config secret or whatever happens, Kubernetes API will notify Flux, and Flux will automatically reconcile the thing. So It's
Using the
an
watching button.
optimization. Yeah, it's an optimization and also let's say a good improvement from a user perspective, user experience, because well, you don't need to worry, you just change the configuration and Flux should react it. So that's what we are discussing here. And
Yeah, it's like basically aligning with what we normally recommend for sources, right? Set the source with a low interval, but set the applier with a high interval.
and the
So
problem is people don't
yeah,
do that because they have these config maps and secret references and
yes.
messes up the whole thing. Then they say, oh, our Kubernetes API is it's under pressure, right? So we concluded the watch should be inexpensive when it comes to config maps and secret. It shouldn't add much load. It's a single connection. It's a persistent gRPC connection.
Yes.
Each watch,
That will
right?
be yeah, feeding the informer, it will do a list watch.
List by labels.
The list watch will stay
Most importantly, the filtering is in the API server by label.
yes.
Otherwise, we are fine.
Yeah, this is a list watch with label selector, and you can give it a bookmark, but we probably won't do. I think controller runtime might have something that handles that. Anyway, like the API server should know like where you're at in terms of history before feeding
Oh
you.
yeah, the control runtime watcher says the bookmark. Yeah. My question was, I'm not sure from the control runtime code. If I have a watch, so now we have watches for sources per kind. We have a watch for Git repo. We have a watch for bucket. We have a watch for OCI repo. So there are 3 watches now in customized control. We are going to add another 2, secrets and config maps. Will that add 2 more HTTP2 persistent connections to the API, or control runtime opens a single HTTP2 connection for all the watches?
The transport should be multiplexed over a single HTTP2 connection.
Yeah, like it's
but
a
the
feature
requests-
from HTTP2, right? The Glib should leverage that.
You should be passing it the same connection. Yeah. Like in Go, you can control that, but yes, we should be on the same. I think that's
So
because you're using the same client.
we use the same client, of course.
The
Yeah.
transport is on the client. Yeah.
Okay, so the load should be really, really minimal. I mean, the only load is Kubernetes API sending us config maps and secrets over the wire when they change. And if we limit those, send us only those with this particular label, then we shouldn't blow up the usage of the memory or the
But
CPU on the Kubernetes API.
the events only send the references, right? We have to get or not. The controller runtimes like receives the event, but then it has to ask for
No, the whole object is cached. The objects that you watch for are cached in the local controller.
and how is that gonna communicate with the feature we have that is a feature gate for caching config maps and secrets? We have that feature gate.
You need to figure out, I don't know. We have currently disabled that.
Okay. Yeah.
I would presume that we would deprecate the old stuff because it's just kind of a non-starter, at least for Helm. And anybody using Helm, right? Like the secret storage just gets so massive because the charts are in there. So, or rather, the rendered release is like in all of the charts, so like it just gets way too massive. That's
Yeah, we need to make sure we'll never receive or watch those secrets, and we wouldn't because they will not have the Flux CD label, right? That's not the problem. The problem is that currently we have disabled completely
by default.
when the controller starts. it disables
Caching,
the
config maps and
caching,
secrets.
config maps and secrets. And my understanding from reading the watcher source code, I did it a long time ago, maybe it changed. My understanding is that you can't create in control runtime a watch for a resource that you have disabled caching.
Well, that should be easy to
Maybe,
find out.
yeah,
The
yeah.
first time I tried this code, oh no.
You guys
Yeah.
just gave me an idea. I think the most secure implementation of this is, of course, by default to require that. I'm saying a wish list of things. Um, it's best, right, if we have people label the secrets. But if the label selector is configurable, technically you can say watch all secrets where the owner is not Helm. And you could watch
Mm.
everything
Mm.
that's
And you
not.
have one label for Helm and one for customize or something.
Well, no, like what I'm getting at is like if our problem before with the memory usage was all of the secrets from a number of sources, like we can already write a label selector that says not this and not this and not this. Like we can already have a canonical list of things that
Oh yeah, I don't want to go to create a ban list. I want to do this
Yeah.
by
allow list only.
allow. You have
But
to opt in into this.
what I'm saying is if the label selector is configurable and a platform team has long intervals and a decoupling of their configs and whatever, and they don't want to talk to 100 dev teams to update all of their labels or whatever, and they can't do it with admission, and they can't do it for this or whatever. Technically, they could go into the label selector configuration for the controller and say, watch everything, but here's a ban list, right, of stuff to not watch. I'm just saying that
Yeah, I know.
like
Let's see.
that's like
If someone requests it, we can add it. Because this is a
I feel the label
control
select
flag.
configurable, and we should just use the parser from kubectl. But
We do this for sharding. We have all that code.
yeah,
Like in sharding, you say watch all Git
These
repos
labels.
which are not labeled with the shard label, right? And you can do if not else all the conditions in there. It's
yeah. There's no or
we-
in label selectors, but there's
it's a
and there's not.
and yeah, not an and yeah.
Yeah, not and are really powerful for excluding.
So you're saying everything is under match expressions, right?
Yeah.
Yeah. I think uh my instinct would be let's like the label selector for the watch should be configurable, and we just provide a good default. But that would be like the most powerful thing because you could do stuff like that. Like
Oh yeah, for sure it will be configurable. It will be a flag, but it will have a default, and the default is what our convention, the label, and only that condition.
because I bet you for like 95% of people, if they wanted to be lazy, there would be hardly any performance issues. It's really more of a security thing, just like copying secrets into Flux that are unintentional. Like you just don't
Yep.
want that. But if somebody wants to opt in to do that, I would not be concerned from a performance perspective if they could exclude a bunch of stuff. So that's my rant. That's exciting.
Yeah, I mean we'll have a flag exactly like we have for sharding,
Yeah.
but the default will be fluxd.io watch enabled, right? And we pass that.
Toolkit.fluxcity.io.
Yeah, toolkit.flux, and we pass that to the label selector construct. Now, if you set the flag and you say not Helm, that's what the watcher will do, right? We don't care. We just compose from the flag the condition, the label selector, and we set the label selector in the watcher. Now
Yeah.
our default is opt-in. You really need to put this label on. But if you want to put there an expression that's supported by the label selector,
Hmm.
you can do
Yeah,
it.
by the label selector of the watch, right? Anything that is
Yeah.
supported by the watch.
Yeah.
Yeah.
And it's the same stuff that we do currently for
Sharding.
sharding. Sharding is the same stuff. We limit the watchers in the controllers to only react to changes
Ooh,
to the
guys,
things that are sharded. Yeah.
it works with sharding. This works with sharding too. Like you could have multiple instances of Helm controllers looking at different pools of secrets. It, that's really cool. Right? Like I
Oh
could,
yeah, of course.
yeah,
I
it's
mean,
I didn't expect it,
uh,
but yes, of course it should work. But yeah, that's really nice. You can
You
configure
would be
different,
setting those things together, right? Like the sharding flags and the
yeah, you're like, hey,
config map and
yes.
secret
only watch
flags.
big maps from my tenant, or whatever. That's really
Yeah.
fuck.
Or my shard.
I'm really,
Yeah. So basically, instead of setting watch enabled, you'll say watch shard 1, shard 2, and whatever, right? So you'll
oh,
need to use
that's
the
so,
same key
yeah.
for the sharding and for watching secrets. So we don't pollute the memory of all the instances of Helm controller with all the secrets if you don't, right? Because it's tenant wise, right? That's why you do sharding. It's not sharding because you want to split things otherwise. So yeah, of course. We need to write a bunch of documentation for this anyway,
Oh,
because no one will know how to use it properly.
um, I mean, yeah, we do a great job. I think the standard of docs and examples across the entire Flux project is way higher than a lot of very successful and large open source projects. Yes, I agree.
Okay, I need to run, guys.
So
Dipti is off
left
already.
a message. Yeah, she left a message here about Azure DevOps commit status. Can we tell her in the Slack maintainers chat to go on?
Maybe the contributors chat. So
Yeah,
yeah. I think let's save the maintainers chat just for
Oh yeah, she should open a pull request. I forgot about this. Yeah,
yeah.
of course.
Helps with the RFC progress.
Okay,
Cool.
cool. Have a nice day, everyone.
Great chat
Bye.
today.
I love working
Yep.
with all.
Interesting
Me too.
discussion.
Bye,
See you guys.
Bye,
Bye.
Kindan.
Yeah.
Bye, everybody.